Okay. So let's look at how we can automate a process like the one that we hacked together yesterday. And actually what we might do is have a look at something that Radek put on the forums. Because I kind of want to have all the stuff we want to include there, and then we can automate the whole thing. Yeah, here's Radek's thing. Okay, so Radek, do you want to tell us about what this thing is? What your
what
project or goal, or what is, yeah, what's this forum post about?
This is yet another of Radek's crazy inventions, but essentially this is how I learn, right? So if and this is the fast AI way of learning, at least I think of this as the fast AI way of learning. Because
so what does it say? Can you just, so for those who haven't read it yet, can you just take us through what it is?
Oh yeah, absolutely. So yesterday in the walkthrough, we covered some material, and I wanted to find a fun way to practice it. So I went to Kaggle, I looked for competitions, and there was a competition that seemed like participating in it could allow me to practice what we learned about in the walkthrough. So I created this as a resource for others. You know, I've been creating such things for a couple of years now, and maybe it requires also a little bit of understanding of Kaggle, which somebody who has not played around with Kaggle yet, they might not have it. So I thought, hey, let me put this together, share it with others. So this is a getting started pack with a community competition. It features images of plants, and you're supposed to detect 1 of 9 or 1 of 10 classes of plant diseases that they can be affected with. I haven't looked too much at the data. Essentially, I relied on FastAI's functionality, where if I present the image data loaders, and then by that token, if I present the learner with data that seems to be appropriately formatted, then the learner will do the rest. So I tried to breeze through this as quickly as I could, just to put it together and to practice on my own as well while doing this. And hopefully this can be useful to others.
Great. Shall we try going it through together? Somebody's got a fast AI one here already. Sounds fun.
Yeah.
Let's try it. So that's great. And I like the fact that you're looking to run it on Paperspace rather than on Kaggle. I think that's good practice. So let's do the same thing that Radek did. So yeah, so on Kaggle, you can see all their competitions that are running, active competitions. So there are various different types, right? There's kind of the normal ones that have money involved. And as well as having money involved, they also have ranking points. So that gives you the opportunity to try to become a master or grandmaster or whatever by getting ranking points. Then there are some which are just for kudos. So there's no money involved and no ranking points. And you can kind of use the little buttons at the top to find getting started competitions. So those are just knowledge. Some have prizes. I wonder what prizes they have. A TPU start, 20 extra hours of TPU time for 4 weeks. There you go.
Kind of sounds like a drug. Like you use TPUs to win, and then you need more to keep going.
I love it. And then there's also playground competitions, which they kind of repeat each month. All right, so looks like Radix picked out a kudos competition, so we're not going to get any money or ranking points. We're just doing it for the enjoyment and the learning. So we have to click, before you can download the data, you have to click join competition. And this is a really common mistake people make, is they try to download the data without doing that, and you'll get an error. So as it says, you can download download the data by running this command here. Now, that's not going to be installed yet, so we need to install it. So we can install it with pip install -- user, etc. I feel like given how much we're typing pip install -- user, whatever, it might be worth creating an alias for. This is taking a long time.
Do you like Paperspace so far generally?
Very, very much. Yeah. Yeah. It's the first platform I found which I feel like I can use this, you know. Yeah. Except it's not
Nice. I have to give it another try then.
not opening my Jupyter Lab. Yeah, make sure you do all the previous walkthroughs, because it really does take you through like how to take advantage of this. And it's yeah, otherwise it's not particularly exciting. All right, I'm having some trouble with Jupyter Lab, so I'm just gonna go to and use their rather unappealing GUI. Hopefully that'll work. No, even that's not working.
Do they have the ability to SSH into these machines? Do you know?
They do not. But because you've got Jupyter Lab installed, you get a full terminal. So it doesn't really make any difference. And you can also connect VS Code to them. Anyway, for some reason, this is the first time this has happened. It's not liking me.
I can't open a Jupyter Lab notebook either.
Oh,
It's timing out. I'll see if I can fire it up in VS Code though. It's unusually sluggish today.
This is my experience whenever I've tried it before. Maybe it's just
Yeah,
I'm here, so the curse came with me.
It used to happen to me all the time, and they seem to have really improved. I'm going to try a paid
I've never had an
one.
issue before.
I'll try a paid one. That helps.
I have a green dot. It's promising. Wait, where did the green dot go? That was the other machine.
I've got two
I guess.
tabs. Yeah, so the green dot is the
It's the free one.
free one.
I can't
Yeah,
connect through VS Code either.
not even wanting to start. Yeah. All right.
Should be a red dot.
Hmm.
But it's not working.
No worries. Change of plans. We'll do things locally. We will yell at Paperspace. Yeah, what the hell just happened? So let me just switch to my other user. Okay, so let's see if Kaggle's installed. No, all right, there's no Kaggle. So here I am with no Kaggle. So I would generally, start by creating a Tmux session because I like to be able to run a few things at the same time. And I would run pip install -user Kaggle. There we go. Now, Kaggle is not just a Python library, but it also has a command line tool. And because I did --user, it installed the command line tool into my home directory, into the .local folder. And binaries, things that you can execute, are generally put in bin. But .local/bin in my home directory isn't in my path, and therefore I can't type Kaggle. Okay, so as we know, to fix that, if you're on Paperspace, you would modify /storage/bash.local, or here in my local machine, I would just modify my home directories .bashrc.
So on Paperspace, if you do this, if you modify bash.local, it will not run before Jupyter Notebook runs. And
correct, which is fine.
oh,
Yes.
okay.
Yes, because Jupyter Notebook doesn't need access to this unless you want to do !Kaggle. If you want to put !Kaggle in Jupyter, you would need to put it in pre-run.sh. Is that your point there?
That it is, yes.
Cool, cool, great. Yep. Yeah,
One
so
question
stuff in
is,
.bash.local only will execute in a new terminal. Sorry, go on.
So I suppose like in some operating systems, I think the local bin directory is on the path by default. So maybe, do you think that it's just,
I've never
whatever
seen that,
reason-
but it's possible. There's a
Oh,
lot of
okay.
distributions around.
I could be confusing with like user local bin or whatever.
Could be.
There's some of them on Mac that are.
Yeah, /users there on Mac /user/local/bin is not in your home directory, and that is always part of your path. But this is something in your home directory.
Oh yeah, okay.
All right. Okay, so by default, Ubuntu has a bunch of stuff in your bashrc, by the way. So I'm just going to go to the bottom. So to go to the bottom in Vim, it's Shift-G to go to the bottom. And then O to open up a new line underneath this one, so insert beneath. And so we will export path equals ~/.local /bin. And then colon, and then everything that's already in your path. So that prepends it to our path. So I could close and reopen my bashrc, or I can re-execute it, and any exported variables I want to go into my shell. So to execute stuff and put variables into your current shell, you can type source. So source.bashrc is going to save me having to close and reopen my terminal. And .bashrc is the last thing on the last line, so I can just do that. And so now we can Kaggle. Okay. So the next thing we need is some way to authenticate, and Kaggle uses something called Kaggle.json to do that. So if I go to Kaggle, you can grab it. There we are. You can grab it by clicking Create New API Token. And what that'll do, just a moment. Is it'll download a file called kaggle.json to your computer. And so once it's downloaded, depending on where you are on Mac, it might be in your /downloads directory, and on Windows it'll be in /mount/c is your like Windows C drive, and it'll be in your username downloads directory. So they say it needs to actually be in a directory called .kaggle. So I'll go make dir.kaggle. I think it's probably just created that for us when we tried to run it. That's good. So now I can copy it. And in this case, I think what I'm going to do is just copy it from my other account. Copy.kaggle / there's my JSON, and I'll copy it into my. By the way, so I want to get the JPH00's home directory. So ~JPH00 refers to the home directory belonging to JPH00. Tilde on its own means the current user's home directory. So I'm going to copy it over to cat.kaggle. There we go. And change its ownership so it's owned by JPH00. So you won't have to do this because you'll be downloading it and copying it from your downloads. I'm just doing this because I'm copying it from a different user. All right. So yep, that now belongs to JPH00. So now I should be able to go back into that username and type Kaggle. Okay, great. So I've got Kaggle installed. And we'll do a check from time to time to see whether anything's working. Not really. Okay. So the Kaggle competition said we can download it with this command, so I'll copy that. And let's create a directory for the competition, Patty, and run that command. Nice. Gigabyte of data. All right. Did anybody have any questions or anything about this as we wait for that to download?
So, Jeremy, we can use Mamba install here since you're doing it on local, right? It's just that you're demonstrating Paperspace.
Yes, if it's on, yes, it is on. It is on Conda Forge. So yeah, Mamba install Kaggle should be fine. Although, you know, to be honest, like for simple pure Python stuff like this, I often just use pip anyway, because things like this, like pretty much most tools are pip, like Python libraries, like pip is the main thing people are kind of targeting, so you can be sure that that's going to be the most recent version. Unless the documentation explicitly says, like, we provide conda packages as well, there's often a good chance that the conda packages will be behind. So if I was going to do a Mamba install, I would be inclined to like double check that this is actually the most recent version. But yeah, I mean, as you see, I just use pip anyway, I suspect, for something like this.
Did it used to be the case that you I remember something about like cookies and there was a browser extension and maybe you had your own tool for this, or am I just hallucinating? Did it used to be this way? From like an older fast AI? Okay.
Okay, so they're always zipped things, so we can unzip it. Okay, so I hate it when that happens because it actually takes ages. So -Q for quietly unzip it. Right. Okay, so that's going to give us our data. I guess one thing is for getting our Kaggle.json onto Paperspace, the easiest way is to click the file upload button in JupyterLab. So there's just a little upward pointing arrow button. If you click that, it'll upload it. And then yes, copy it to /.kaggle. And it does have to have the correct permissions. Which is, hopefully you might be able to recognize this. So that's 4 + 2 is 6, and then 0, 0. So chmod 600 on that file will give you the correct permissions. Okay. So, now the only problem is that this is my desktop, which does not have a GPU. So that was actually a stupid place to put this. So I'm going to copy this to my GPU server. So to copy files from one Linux or Mac thing to another, very easy way to do it is SCP, secure copy, and type the name of the file, and then type where you want to send it to. Except I don't have that set up here. All right, so I'm just going to go back to my normal user. Sudo copy ~jph00 get patty disease classification. I'm going to copy that here. ch own j howard. That. Okay. So you can use SCP to copy a file to another machine. And off that goes. So how does it know what local colon is? There's a very underutilized handy file called .ssh/config where you can type things like host local, and when I SSH to that, it will actually SSH to this host name, and it will actually use this username, and it'll set up, we haven't talked about SSH forwarding, but if you know about that, it'll set up SSH forwarding. So this is just a little trick for people who do use SSH, that using the SSH config file is great. And it's not just for SSH, it's also for anything that uses SSH, including SCP. SCP is a secure copy over SSH. All right, so now that's done, I can log in to that machine. And now we're on a GPU machine. So to check your GPUs, you can type nvidia-smi. And so this has got 3 GPUs. And I can move that file I just copied into here,
So should we use SCP or rsync?
Either's fine. Yeah. I use SCP just because I don't have to type any flags to it. Strictly speaking, SCP is kind of considered deprecated nowadays, but it actually works fine. Unzip that. Cool. Okay. Making good progress. Let's see what we've got. Okay, so there's a sample submission.csv, there's a train.csv, train images, test images. So ls train images, if this has got like 10,000 things in it, that's going to be annoying. So if you pipe to head, so remember this vertical bar is called pipe, means take the input of this output of this program and pass it in as the input to this program. And this program shows you the first 10 lines of its input. Okay, so actually it turns out that's got folders for each category, so I don't really need to pipe it to head. Okay, and so then we could do the same thing with one of these, bacterial leaf blight, and pipe that to head. There we go. So now we might want to know like, oh, how many of those are there? So instead of piping to head, we can pipe it to word count, which is WC. But despite the name, it doesn't only count words. If you pass in L for line, it'll do a line count. So that's how many bacterial leaf blight images there are. So it's really useful to, yeah, you know, play around with these things you can pipe into. So head, WC, another useful one is tail, which is the last 10 lines. And then one we've seen before is grep. So not particularly useful, but show me all the ones with the number 33 in it. Okay.
And you can use head and tail also on files. So head is very useful for CSV files.
Mm-hmm.
If you're in your Jupyter notebook and it's screaming at you that it cannot read a CSV file, it cannot parse a CSV file, you can just jump into console or even from Jupyter notebook, just do head.
Yeah, well, let's try it, right? Because so I think we know that if you type cat and a file name, it will send it to the output, which by default prints it to the screen. So we could pipe that to head, right? Now, real Unix gurus will say, well, that was silly because actually if you look up the man page for head, if you pass it a file name, it does the same thing. But to me, I prefer to learn a smaller number of composable things. So piping stuff to head is not a bad idea. And we could even, and you know, another nice thing about cat is I can pipe it into grep and search for everything with, I don't know, how many of these ADT45s are there? Let's grep for ADT45 and then pipe that into word count, but count lines. Whatever, ADT. Yeah, so you can, you know, quickly get some information at the console, which, yeah, I think can be quite useful. All right. So next thing to do, I reckon, is to fire up a Jupyter. So let's cd git Jupyter Notebook.
Excuse me, Jeremy, if you're interested, my Paperspace Jupyter instance is started up now.
Hooray.
So I don't know if yours would have to.
Look at that. Fantastic. All right, so it's probably worth just quickly going through the exact same process one more time, I guess, isn't it? So we'd open up the terminal, pip install Kaggle -- user. Ah, that's interesting. So this is because I installed stuff to that conda directory the other day. And so if I go which pip, it's actually finding that one. And I don't want there to be a pip there, so we'll remove it. Conda, oh, in my home directory. Okay, let's try that again. I wonder if I have to reopen this terminal. How confused is it? Which pip? There we go. Okay, now it's happy. Control R, install, to find the last thing I typed, saying install. Okay, we got the path issue again. So vim slash, I think I prefer Radix approach of putting it in pre-run, so that way we have the ability to use this if we wish in Jupyter, not Echo. So export path equals dot local bin, and then the current path.
One of the confusing things I find about Bash, and it got me a couple of times, if you are doing export something, a variable name, you need to have the equality sign straight after the variable name.
Oh
You
yeah,
put a
no
space
space.
there, it won't work. And you know, it's just one of these little quirks where things
Crazy.
are different. Yeah.
Yeah, you know, Bash is a very old program, and it has these weird old quirks about white space sensitivity. So that's a really important point to mention. Thank you. And I'll run it here as well, rather than restarting. And so now Kaggle should exist. It does, it runs, that's good. All right, and so let's copy this into my downloads directory. Or else, I guess what I could do, yeah, let's just do that. Copy /.kaggle /mount/c users j downloads. And so we should be able to now upload it from my downloads directory. There it is. Okay, and so it's created a .kaggle directory for us. Wait, oh, sorry, this is my wrong. Sorry, let's do that again. cd /.kaggle. Yeah, it's created a Kaggle directory for us. And so we should be able to move the thing that we just uploaded to /notebooks into here. And the permissions will be wrong. So we can fix them. Okay, and so let's see if it works here as well. It does. And Paperspace's network is faster than my connection in Australia, not surprisingly. Although, you know, mine wasn't bad actually. Okay, so oh, that was a dumb place to put it. Obviously, I don't want to put it in Paddy disease classification. You know, we're only going to use this for this notebook, I guess. So maybe move that to /notebooks. And so let's create a Paddy folder. Pop it in there and unzip it. So that means, okay, that's interesting. There's no unzip, but we know how to deal with that. Why isn't Control R working for me? Oh, because Control R does a refresh. Oh, that's annoying, isn't it? So how do we search our history? In these terminals. Oh, well. That's fine. I will just type it in manually and we will figure out how to make Control R working at some other point. Micro member minus C conda forge minus prefix tilde slash conda install. Probably need the install first. Yeah, a lot of the keyboard shortcuts don't work in the browser-based terminal, which is actually pretty annoying. They work a bit better on Mac than on Windows, because on Windows, the control key is both used for the Linux terminal commands, and it's also used for like the normal browser commands, whereas on Mac, they use command for the browser commands. And so the control key doesn't get overwritten. So this would probably be a better experience on Mac actually than Windows. Okay, so we're going to install Unzip. And hopefully by the time people watch this video, if it's like July or later, things like Mamba and Unzip will already be installed. Okay, let's check. Okay, we have an Unzip. That's good. Okay, so that is on its way. So that's going to use up a gigabyte of space in my persistent storage, which you might not want to do that, right? And if you don't want to do that, then instead you should unzip it into your home directory. If you unzip it into your home directory, it won't be there if you close it down and reopen it, right? So you might want to create a little script for yourself that does the Kaggle download and the unzip on your notebook, and then it'll run that each time you start it up. So these are the issues. I mean, look, having said that, the overage cost on Paperspace for storage, I believe, is 29 cents per gigabyte per month. So the convenience of putting it in storage is probably worth 29 cents for the 1 month. You're probably going to want it there. So maybe that's just a better plan. I do know though that well, maybe this is a problem actually, because I do know the Paperspace / notebooks and / storage are very, 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 very slow. And we can actually see that when we're unzipping this. So maybe this is a bad idea. Maybe we shouldn't put data, at least when there's lots of files, because this is painful. I'm going to cancel it and just see how far it got. du minus sh train images 426. And how about test images? Wouldn't you know it, it was nearly finished. But yeah, I think this is actually slower. So I'm gonna remove that. Oops. And I have a strong feeling if we move it back to our home directory, it's going to be faster. I sure hope so. And the reason I care is not so much for the unzipping speed, but when it comes to like training a model, we don't want it to be taking ages to open up each of those files. Wow, you see, even rm minus rf takes a long time. So while that's running, let's move patty / zip file, pop it into our home directory. There we go. and then cd to our home directory. Okay, that's now finished. So in terms of the steps we're going to do, it would be, first we would make a directory for it. We would then do the Kaggle download. Actually, which we can just copy easily enough from Kaggle. And then we would unzip. Let's see how long it takes. So the time Unix command runs whatever command you put after it and tells you how long it took. Did I not move it there? Move /paddy. Oh, I didn't move it there. Yeah. Time, unzip, quietly, paddy. So yeah, so I think what I would do, now I think about it, is I would have a paddy directory in my notebooks. I wouldn't store anything big here. I just have my notebooks here. And I would put a script here called get data, say. And it'll just have each of the steps I need. So the steps would be cd to my home directory, make the paddy folder, cd to the paddy folder, do the wget, or not wget, Kaggle competitions download, I should say, unzip it. Paddy disease. Yeah, and I think that's it, right? So we can make that executable with chmod u plus x to add the executable permission to it. And so, yeah, so then all I have to do is run that thing each time I start up Paperspace. And yeah, it's only going to take 8 seconds to unzip, and it took about 5 seconds to download. So actually, that's not going to be really any trouble at all, is it? Cool. And that's, /notebooks, remember, is persistent on this machine. So that's all good. So now we can create a notebook for it. And so my first step is always just to import computer vision functionality in general, which is the same thing we used yesterday. And now you know exactly what that does. And then my second step is to look at the data. So it's easiest to look at the data if we set a path to it. So it's going to be in our home directory. And it's going to be called paddy / well, that's okay. It's just /paddy, right?
You can do path that home. Wow, I didn't know that. That's quite neat.
And no slash at the end. Yeah, it is quite neat. So that's that. Okay. So we can path.ls tells me what's in there. And if you remember my trick from yesterday, I also like to set that to be the path.basepath, just so that my LSs look a bit easier to read. There we go. So at this point, we could create a data frame by reading in the CSV of path/train.csv. Okay, so we've got 10,000 rows. Each one is a JPEG. Each one's got a label. And so let's take a look at one of the images, shall we? Oh yeah, PIL image. Path slash train slash. Actually, let's make life a little bit easier for ourselves by creating a train path. Because, it's just so good to be lazy. Slash 100,330.jpg. Pig. Oh no, because then they're inside the label directory. Yes. So what we actually probably should have done would be to say trin path.ls. Root patty train, is that not right? Train underscore images. And that's another good reason to put it in a variable. So you only have to change it in one place. And so there we have that. And so let's create, I don't know, let's call it the bacterial leaf light path equals train path slash bacterial leaf blight. So now we should be able to go BLB and look at that image. Oh, there we go. So we have an image. Yay. All right. So might be nice to find out a bit about this. Maybe look at the size. So it's a 480 by 640 image. Great. Another way we can take a look at an image, you might remember from yesterday, you can go files equals get image files and pass in a path. And this will be recursive. So I can do this. As you can see, so this has got the 10,000. Okay, and that number there matches that number there. So that's a good sign. Right. And so another way to do that would have been to go image equals pil.create files 0. Okay. And we could even take a look at a few, right? So if we wanted to check that the image size seems reasonably consistent, we could go o.size for o in, well, actually, pil image dot create o dot size for o in files 10, for example. So, this is not particularly rigorous, but it looks like they're generally 480 by 640 files. They're all the same size, which is handy. That's interesting. And they're probably bigger than we normally need. We normally use images that are around 224 or so. Having said that, I don't know if like presumably this is some disease thing, paddy disease competition. So it's rice. Classify the images according to their disease. So I can't even tell that this thing has a disease. So I don't know how big it needs to be to see the disease. So it is possible it'll turn out that we actually need full-sized images. So like I would start by using smaller images and kind of see how we go. Anyway, 640 by 480 is not giant, so we should be fine. The CSV file has got one extra bit of information, which is the variety. Radek, did you find out what this variety thing is about?
I have not found it out. I didn't even know that that CSV file existed. But it's fun because we can build a multimodal model on this data.
I see. It's the type of rice as opposed to the type of disease. Yeah. So maybe you know, the different diseases might look different depending on what type of rice it's on. My guess is that we wouldn't need to use that information because given how many images there are, I would guess that it's going to do a perfectly good job of recognizing the varieties by itself without us telling it. Unless there's a whole lot of different types of varieties, which we can check easily enough, right? By checking the data frame, grabbing the variety, and doing a dot value counts. And we can see how many there are of each. Okay, so there's not, okay, so look, I mean, there's a couple of tiny varieties, but on the whole, most of it is ADT45 and quite a bit of Karnataka Ponni. Does seem like a bit of a rice session today, doesn't it? Lots of rice going on. Yeah, so I think it's very unlikely that this variety field is going to help because there's so many examples of the main one anyway that it's going to be able to recognize it. I mean, at some point we can try it, but I would be making that a pretty low priority for this competition. And so, yeah, given we're doing a practice walkthrough, I'd be inclined to fire up Fastbook and the intro and see if we can just basically do the same thing that we did last time. So I'm going to merge these back together again. We've already got those two. We've got those. Well, no, there's not much there, is there? Oh, I'm in APL mode. No wonder my things aren't working. Don't know how that happened. Haven't used APL today. Copy. Paste. Okay, so this is how we did cats. So we needed a labeling function. Now in our case, the labels are very easy. Each image is inside the directory, which is its label. So the parent folder name is the label. And so we already have a function to label from folders. So we can actually just do image data loaders from folders because that's all we need. So we're still going to need the path. Train and valid actually have different names. So let's fill all of those in. So we're going to have path train equals train underscore, what was it? Images? Images, yep. And test images. Train underscore images. Valid percent, so that's fine. We'll do that the same as last time. Okay. It's expecting to have train and valid subfolders, or valid percent. So hopefully that'll work. Let's try it. And we'll use the same resize as last time. Okay. Hooray. No, that did, well, did that work? No, it didn't work. Because we've got, that's interesting, test images. So my guess is it's got confused by the fact. Yes. Okay. So possibly what we should instead do is use train path here. And use valid percent instead. I wonder if that'll fix that problem. There we go. Let's fix that problem. Okay. Great. So we should then be able to create a learner. And learn dot fine tune. Let's just do one epoch to start with. There it goes. So it can be useful to kind of make sure it's being reasonably productive as it's training. And we can do that with nvidia-smi. nvidia-smi minus help. Oh, so much help. So there's, let's take a look here. We've only got one GPU, so that's fine. Loop, query. Okay, we're not modifying anything. Dmon, I think that's the one we want. nvidia-smi dmon. Okay, that just finished. So while it was running, so this is something people often say to use watch nvidia-smi to like have it refresh. But actually, I don't think most people know that there's a dmon subcommand where you can use that. Just as you can see, it shows you every second how it's going. And it's showing me the most important thing is this column SM. SM stands for symmetric multiprocessor. That's kind of what they call it instead of a CPU for their GPUs. And it's showing me that it's being used 70 to 90% kind of effectively, if you like. And that's a good sign. That's fine. So if this was like under 50, then that would be a problem. But it looks like it's using my GPU reasonably effectively. Yeah, and it's got the error rate down to 13%. So we are successfully training a model. So that sounds good. So
Jeremy, just a
yeah,
quick question.
anytime.
When you're saying that, like, if it's under 50%, then that can be a problem. Is that because you've oversized the GPU, like when you selected it, or like just wanted to clarify what you meant by that?
What that would mean, yeah, thanks. It's a good question. I'm just going to rename this. It would probably mean that we're not able to read and process the images fast enough. And so in particular, my guess is that if they're in /storage or /notebooks, you would see the SM% be really low, because I think it would be taking a really long time to open each image because it's coming from a network storage. And so generally, yeah, a low SM means that your IO, your input output, your reading or processing time is too high. And so the ways to fix that would be a few. One would be to move the images onto the local machine so they're not on a network drive. A second would be to resize the images ahead of time to make them a more reasonable size. And a third would be to decrease the amount of kind of augmentation that you're doing. Or another would be to pick a different instance type with more CPUs. So those are basically the things.
Perfect.
All right.
Thanks.
Okay.
Just the nvidia-smi command, it also has a lot of useful information, like your CUDA version and stuff like that. So, you know, it's also a useful command even without dmon to know that it exists. Yep, should have, a lot of details here. So if you're looking for the IDX of your GPU, you have multiple GPUs, and some of the variables here are a little bit more descriptive. So it might be easier to get started with that command, or to at least use it every now and then. And if you'd like to have this one running in a loop, which is what I generally do, you just do nvidia-smi -l. And you get
I mean, I agree this is useful, but I would suggest in a loop to use the dmon, because there's only two columns you care about. It's the, and this one does not show you SM, right? So if you want to actually see it's being utilized, you need to use dmon, and you can also see the percentage memory utilization. So just look at these two columns. The other ones you can actually ignore. Yeah, okay. I think that's a pretty good place to stop. I'm glad you put us onto this competition, Radek. It looks fun, and I feel like we've got a reasonable start. So yeah, maybe next time we can try doing a submission. And we could also try creating a Kaggle notebook for other people to see. How does that sound?
Sounds excellent. One thing I also like about this is that we're coming up across problems as we go, and jumping through those hoops, and and these are the beginner sorts of roadblocks that we'll have to face, I guess. So
exactly, and
super valuable.
If you guys, repeat these steps or do it on another data set or whatever, and hit some roadblocks, then it's really helpful. If you've solved them, come back tomorrow and tell us what happened and how you solved it. And if you didn't, come back tomorrow and tell us to fix it for you. I think they're both useful things to do. So things like Radek's example of like doing a bash environment variable and having a space next to the equal sign, that kind of stuff. I forget even to mention it, but really useful information.
This competition is nice because it's relatively small, like 10,000 images, and it's aligned with what we're doing in the course. But if you'd like to try something out on a competition that is not active right now, you can still do this, because Kaggle allows you to do this late submission thing.
Good point.
And this opens up many competitions to you to play around with. The current competitions that are how do they call it, ranked competitions, so they award you points and there are prizes. They are not on images, so we explore something on your own to try the methods on an older competition on an image dataset. That might be something quite useful.
So to find those, you'll need to scroll to the bottom and click explore all competitions, and yeah, this will let you see closed competitions as well. And you can even see, I guess, here you go, you can find out which were the ones with the most popular of all time. That can be interesting. Crypto forecasting. Well, of course it would be. That's a bit sad, but there you go. That's interesting. This patent phrase one is super popular. That's good to see. Instant gratification. All right. Thanks all. See you next time. Bye.
Yeah.